All right, so here is our last example. Again, I suggest you pause this video and try it yourself first before looking at my work. So the first thing that we want to look at is what we can do to simplify this one to find the simplified expression. Hopefully you notice this as a difference of cubes, or using what we often call the SOAP method of factoring. So factoring this one, it's going to be x and a 3. We have x squared and 9 and 3x. And it's same sign, opposite sign, always positive. And then that denominator is just going to have a 5 factored out. So the simplified expression, the x minus 3's cancel, and we have this. Excluded values, x cannot be equal to 3. We know that excluded value is either going to be a vertical asymptote or a whole. It was something that canceled out, so we know that it's going to be a whole. That 5 has no x attached to it, so it's not vertical asymptote, that's just a coefficient, so there are no vertical asymptotes. So let's go ahead and find some other things. I'm going to do everything that we plug in. So for my y-intercepts, I'm going to go ahead and plug in 0 for x. You can plug it into either version. Again, I like starting with the original one. So we get that the y-intercept is this negative 27 over negative 15, which is equal to positive 9/5. Other things we plug in, we know to find the whole, we're going to plug 3 into the simplified version of it. And again, we want to plug it into the simplified one because if you plug it into the one before you canceled, you're going to end up with 0 over 0, which is not a number. So I'm going to go ahead and plug in that 3. And that's going to be 9 plus 9 plus 9, or 27/5. Let's talk about now my horizontal asymptotes. I think those are going to be easier next. So we're comparing the degree of the numerator to the degree of the denominator. The numerator degree is 3, denominator is 1, so it's top heavy. So there is no horizontal asymptote. There's also the difference of the degrees is more than 1, so there is no slant asymptote. So then x-intercepts. Looking at the x-intercepts, we know that can be where the numerator is equal to 0. X minus 3 gave us the whole, so we're just going to set this part equal to 0. So I have x squared plus 3x plus 9 is equal to 0. Trying to factor that. Two numbers that multiply give you 9, add to give you 3. There isn't one, so this actually cannot be factored. We could try the the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. But we do notice when we're looking at this that this is a negative value, so there are no x-intercepts either, no real numbers at least. So there's also none when it comes to the x-intercepts. So this one's actually an interesting graph. And when we look at it, we can see that it ends up just looking like a quadratic. So when we simplified this, the simplified version was just this quadratic. We could plug in some points to find that. I did put the t-chart here because the graphs on Desmos don't show holes, but we can see at 3 it is undefined. So at 3, the hole is somewhere up here. We know that that's going to be 27 over 5. No horizontal asymptote, no slant asymptote, and no vertical asymptotes.